e to the negative sign of t, and then dt. Okay, notice I get 196.937 if I'm rounding to 3 decimal places. So that means this is my answer. And what would be my units? Feet. Okay, number 2 says a store is having a 5-hour sale. The rate at which the shoppers enter the store t hours after the sale begins is modeled by the function e of t. When the sale starts, there's already 70 shoppers in the store. Write and do not solve an equation involving the integral to find time x when the number of shoppers in the store is 200. Assume no one leaves the store during this time. Okay, so they give us the information to set up the integral equation. We're not able to solve. We have too many unknown variables. Okay, so before the sale starts, how many people are already in the store? 70. So 70 plus the integral from 0 to x, because we don't know what x is, of the function e of t dt is equal to what number? 200. Okay, that's our answer. I just wanted us to set up the problem. Okay, if they were to give us e of t or x, then we would be able to solve this. Okay. Number 3 says water is pumped into a tank at a rate modeled by R of t liters per hour, where R is differentiable and decreasing on the interval 0 to 8. Selected values of R of t are shown in the table below. At time is equal to 0, there are 5,000 liters of water in the tank. Okay, so here we have our table, and then part A says, what does the integral from 0 to 8 R of t dt represent? Good, the amount of water pumped into the tank, good, during the first 8 hours. So the amount of water pumped into the tank during the first 8 hours. Okay, then it says, estimate that integral using a left Riemann sum. Do you guys remember how to calculate a Riemann sum? Yes, ma'am. Okay, so left Riemann sum means we start at which side, the left or the right? The left. And so in order to do this, let's first figure out the widths of each of these rectangles. So from 0 to 1, that's going to be a width of 1. From 1 to 3 is 2. From 3 to 6. 3. And from 6 to 8? 2. So these are each of the widths. And since it's a left Riemann sum, for the height, we're going to start with the left number, which means we're going to end up using all the numbers except 1,000. Okay, we're starting at the left. Okay, so writing this out, this would be 1 times 3,000, okay, plus 2 times 2,500, plus 3 times 2,100, plus 2 times 1,500. Okay, we're using the width between each of those hours, and we're multiplying it by the height, R of t. Okay, so you can either use Desmos, type that in to get your answer, or use mental math, and you would get 17,300 what? What's the units? Liters. Okay, so remember, the integral from 0 to 8 is saying how much water was pumped into the tank. Did the problem mention about water that was already in the tank? No, read it again. Yes, 5,000, because it said at time equals 0, there are 5,000 liters of water in the tank, which means before they start pumping water in it, there's already 5,000. Okay, so in order to answer C, it says how many liters of water in the tank after 8 hours. We have to take our answer, 17,300, and add 5,000 to it to get 22,300 liters. Okay. Any questions on number 3? Okay, number 4. It says using the same scenario, but this time the table of values represent W of T, the number of liters of water in the tank at any given time T, measured in hours. So now we have our table. So if we're comparing this table to the last table, we have W of T, which is liters, but we had R of T, which was what? Liters per hour. So in order to get that liters per hour, we could say that W prime of T is the same as giving us liters per hour, which is equivalent to R of T. So when part A says, what does the integral from 0 to 8 W prime of T dt represent, it's going to end up representing the same thing that we wrote where? On 3A. So this is still representing the amount of water pumped into the tank during the first 8 hours. So I'm just going to say same as 3A, or if you want, you could write out that statement again. Okay, B says find the integral of 0 to 8 of W prime of T dt. Okay, well, if we take the integral of something's derivative, then really we get the function, W of T. Okay, and then we would solve it from 0 to 8, which is the same as saying W of 8 minus W of 0. And since we have those values in the table, we just plug in those values. So 22,000 minus 5,000, and that gives us 17,000. And then what would be our units? Liters. 17,000 liters. Okay, any questions on 8.3? Easy peasy.